In this video, we will talk about what a set is. And I want to begin with a definition. So the definition is that a set is an unordered collection of objects whose members are specified by a list or a rule. So I'll give an example in a sec. But I want to briefly talk about this word unordered. So when it says it's an unordered collection of objects, that means that the order doesn't matter. If we were to list the elements, the order doesn't matter in the list. So let's look at an example. In part A, I'm going to write an example of a set as a list first. So let's do it as a list. So I'm going to call my set S. And the way I notate this is I put some curly brackets. Okay, and then I'm going to put some members inside the set. So I'm going to put some states in here. I'm going to put California, Oregon, Washington, Alaska, and Hawaii. And then I'll close that curly bracket. Okay, and this is a set right here. S is the name of the set, and California, Oregon, Washington, Alaska, and Hawaii, those 5 objects, they are the members of this set. So notice that we can also write this with a rule. So sometimes there's a rule that will nicely describe all the objects that are inside of a set. So what would that look like here? Okay, so the way I'm going to write this is S. Again, curly bracket. I'm going to write X, and then I'm going to write a colon, and the colon is notation that means such that. So this means such that. And then I'm going to say X is the name of a US state which borders the Pacific Ocean. So that is a common unifying thread to all of these objects, all of these 5 states that are listed here. So when I use this second notation, how do I read this? Well, we read this as, and I'm going to put it in quotes, S is the set of all X. And then that colon, I know I read that as such that, and then I would just read off everything that comes after it. So X is the name of a US state, so on and so on. So I'm just going to put dot, dot, dot. So that's how I would say it out loud in words. All right, so this was the same set. The one I've written in blue and the one I've written in green, it's exactly the same set, just written in a different way. First I wrote it as a list and then as a rule. Let's look at another example. So I'm going to call this part B. So in part B, I'm going to write a set first as a list. So I'm going to call this set L, and the members of L, I'm going to say are 1, 3, 5, 7, 9. Just going to do a bunch of positive odd integers. 11, 13, 15, 17, 19, and 21. And notice that we separate each of the members with a comma. Okay, so that's as a list. I could also describe this as a rule. And sometimes it's beneficial, especially when my set has a bunch of elements and it's easy to describe them with a rule. So the rule to describe these would be something like, maybe I'll assign the variable n this time to refer to all the elements. So L is the set of all n such that n is a positive, odd, integer, and n is less than 22. So that describes everything that's in this set. Awesome. So these are also the same. They're just two different ways of describing the same set. Okay, so I'm going to introduce some terminology. So if an object y is in a set S, we say y is an element of S. And we would write y, and I put this symbol, kind of looks almost like an E, so this is the symbol for is an element of, and then I write S. So that symbol, again, just means is an element of. So that whole, this whole line was read, y is an element of S. So for example, in example B here, so in example 1b, notice that the number 13 is a member of the set, so I could write 13 is an element of L. And let's give an example of something that's not an element of L. But, for example, 14 is definitely not in L, so I'll put a slash through the symbol. And that just means is not an element of. So in our next video, we will talk about what a subset is.